You getting phone calls right now? All right. Hey, let's take a seat. Take a seat.
Every day in this class, I get another call from the ship. It's one of them actresses.
Every time we get a phone call.
No, this class, every day.
All right. Today, we're just going to do a few notes today. I do want to give you some time where you can work on this page 116. That was the one that is due on Tuesday. That's tomorrow. So I'm going to make sure that I'm going to do, I said about 15 minutes left class-ish kind of a thing. We're going to do a couple notes before that. I want to do at least one example of the repeating decimals. One example where you have to write a decimal and change it back to a fraction. That was one of the things we talked about. Last week we had a shortcut for doing that, but I do want to show you the real process if you want to see it one more time. And then we're going to talk about our new stuff we're going into. Now, reminder this week, at some point this week, you will have a pop quiz over those few sections of chapter 4. Changing fractions to decimals, decimals to fractions, scientific notation, and the repeating decimals. So that'd be our quiz. I expect small, a couple problems of each. Okay? All right. Today, we're going to move on to section 5.1 today, which is called ratios. That's going to be our next topic we're going into. We are going to introduce a couple things to that. The first thing I do want to discuss, we're going to do a couple examples of what our homework is today. I'm going to do a couple examples like I just explained a little bit ago of the homework. Just make sure that you know kind of how to do your homework today once I give you some time to work. So maybe I'll go through 2 examples of that. The new stuff today, I do want to do a definition of what a ratio is. And basically this chapter we can kind of think of is, when we start talking about fractions and decimals, what are the actual uses for it? That's what this chapter is kind of all about. How do we apply it? Because then you guys know the process. You know how to add fractions, multiply, divide, you know how to do decimals, you know how to do that. So hopefully this makes sense now. So we're going to start applying them to actual practical purposes. A lot of stuff we're going to cover seems like review, because it is. It's applying the stuff we've learned to something that we can use it for. Okay, so we're going to do a definition. Maybe we'll do an example or two of what a ratio is, kind of an example of it. I'll do kind of a hands-on activity where you guys can actually practice that. And then the last part of class is where you can actually work on your homework today. I'll give you 10 to 15 minutes to kind of work on your homework. It is, remember, it's due tomorrow. Due Tuesday. Okay. Questions, comments about what we're doing today? Good. Fairly easy day. Okay, let's do an example of one of the problems out of your book. In fact, I'm just going to pull one right out of the book. We're going to take a look at it. Alright, one of our examples. Let's see, I want to go with so this is one of our examples. The goal in this problem, they give you the fraction. This fraction represents a repeating decimal. I want to change this fraction to the repeating decimal and make sure that we put the bar in the correct spot, whatever number repeats. Okay, that's what we're gonna look at. Okay, now when we first do this, what's the process? What do we remember from last week?
33 goes. No, wait, no, the 2 goes inside.
2 goes inside.
33 goes outside.
Good. We're doing long division, right? 2 goes in the house. We put a bunch of zeros back here because I don't know how many numbers I'll need. The 33 goes on the outside. The bottom number always goes on the outside. That's something I do want to see on your paper when you're working. When you're doing your homework, I do want to see that so you can actually prove what your numbers are. Again, you can use a calculator to help you, but again, the actual long division is what I'm looking for. Okay, can 33 go into the number 2? Okay. Can 33 go into 20? No. So right now we have a bunch of zeros. This decimal will be coming straight up here in a little bit. Now we're on to 200. And again, why I picked these, this number has to be smaller than the number on the inside. So that's why I didn't go into 20. That's why we have zeros in there. But 33 can go into 200. It can go in there like 6 times. So, in fact, if we take 33 times 6, you'll kind of see what my number is. 6 times 3 is 18, carry the 1. 6 times 3 is 18 plus 1 is 19, so it's 198. So that is about as close to 200 as I can get. It's 198.
And then it repeats.
Yeah, because now what we're gonna get, when we subtract 200 minus 198, you're gonna get 2. You bring down the next number, and 33 can't go into that, but it can go into 200 6 times. And we'll start this whole process of repeating. So what number is actually repeating there over and over and over? 0, 6, yeah. So the actual number here, the 0, 6 is the number that's repeating. It'll go 0, 6, 0, 6, 0, 6, 0, 6. And this is, remember, this is kind of the goal. This is your answer. That's what I'm looking for. Did you put the bar above the right numbers? That's what I'm checking. Did you do the long division to actually prove that it's going to repeat over and over and over? Question?
And so, if you have like a number out in front of the
Yes.
question, isn't that supposed to go with?
Yeah, so if, make up some random number. 5. Put a 5 out there, the 5 will go here. That's all it is.
Okay.
Yeah, if it's a whole number out front, that's the big number out front of the decimal. Yep, good question. All right, any questions, comments, concerns about what we did last, what was that, last Thursday, Friday? Okay, good. Let's do one more. I want to do one of the ones where we had to make up, because I know we had 5 problems where you had to make up some repeating decimal. Just make it up. It had to be something simple. Okay, that's kind of what I wanted. Anyone still need that? Okay, all right. Let's get rid of this. Now let's talk about. We're going to make up some repeating number. I'll keep it small. So the example I want to go through. Let's go 0. Now let's go 12, and we'll have the 12 repeating over and over again. So what we talked about last week is the actual process for how do we change that back to a fraction of some sort. So that's what we're going to look at. The real process, we have the shortcut, right? When I'll ask you what your shortcut is here in a little bit, but the real process, you take this number, you set it equal to 1x, and you actually write out the numbers that are repeating. You write out the actual number, and you go a little bit. You go a little ways. So I go about 2 or 3 iterations of what number repeats. Okay? So we have the, 0.12, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. All right. Now, how many numbers were underneath the little house? Underneath the capital bar? 2. So we're going to have to move that decimal over 2 spots. So really, this number is going to be 12.121212. And the reason why is this decimal moved back 2 spots. So there's actually 0 up here. Okay, now what number's out front of the x now?
100.
100.
Oh.
Yeah, it's 100. Because you count how many numbers are underneath the bar, that number is how many you put there. Then we subtract, straight down. When we subtract this side, what happens to all these?
They get canceled out.
Yeah, they just, all of them are canceling perfectly. And we have 12 minus 0, which is?
2.
Oh,
Oh,
yeah.
okay.
Oh, yeah, 2 and 1. You're absolutely right. 100 minus 1?
99.
99.
100.
And then the trick? What's the shortcut? Because I know, Alex, you had your hand up earlier.
It's basically just going to be like, let's say, 120, it'd be like 120 over 99. No.
Close. 12 over
I
99.
just confused myself.
Yep. It's 12 over 99. Trick is you count how many numbers are underneath the bar, that's how many 9s go on the bottom. That was the shortcut, that was what you guys figured out last Friday, was the easiest way to write repeating decimals. And again, I know that fraction can actually simplify. If we actually simplify this down, this actually turns out to be 4 over 33. That's actually what it simplifies down into. I'm not worried about that. I was looking for this. That's what I was looking for. The original number. And again, how that was created by what I did over here, this 99 would go on the bottom. So it is 12 over 99. That was the real process versus kind of the shortcut that you guys kind of learned. All right. Questions about the actual homework that we have to do tomorrow? Okay. You will have time at the very end of class. Remember, you had to make up 5 of these and then write them as fractions. Make up any ones that you want. Then you had to do the book assignment, which was this, where they gave you fractions, you had to write the repeating. But I did want to see long division. Okay, today, let's talk about the definition of a ratio. We'll do a few examples of what we're going into, And then the goal today is kind of work on your homework and hopefully get it right with that. Okay, let's jump into it. Let's talk about a ratio here. Okay, I'll leave that in order for a little bit. All right, so definition of a ratio. The good news is we've actually had that word before. It was a long time ago, so when we first introduced fractions. A ratio is a comparison of two numbers using division. That's what a ratio is. Comparing two different numbers, writing it as a fraction preferably, but there's actually a bunch of different ways you can display a ratio. Goal today is to actually talk about it, to actually do maybe an example or two, so you can actually see how ratios work. Kind of a fun little game that we'll play with this. All right, but again, the different ways of displaying ratios. Number one, we can write them as a fraction. That's probably the number one way that people understand what ratios are, fraction. Another way we can do it, we can write it as a colon method, where you actually use like a semicolon on the inside of it, and it's comparison. Your digital clock at home is an actual ratio, and it tells you the hours, the little colon in between the semicolon, and then the actual minutes behind it. It's some type of ratio. Next way, we can write it as a decimal, like what you guys are just learning how to do, right? Changing fractions to decimals by long dividing. We can write it as a percent, which is one of the things we are going to learn in this chapter. A percentage. Those are the different ways we should be very, very comfortable with ratios. Now, let's do an example, and then we'll do kind of a game where we can kind of see how it works. All right, so let's say we're dealing with a deck of cards. Now let's discuss what a deck of cards is. I'll pull out an example here in a minute. Okay? I'm going to look in my categories, Mitchell, and there's going to be a box in the second shelf. Look down, second shelf down from the bottom.
Okay.
It may be like a Staples box.
Okay.
Might be a deck of cards in there.
Didn't break it.
You're just breaking all my stuff, right? Deck of cards. Hey, look, even bigger. Ooh, nice. Deck of cards. All right, this is a gigantic set, so you guys can see it. Okay, hopefully there's no jokers.
I have some cards for me.
I'll have to look at those later. All right. I don't think there's any more jokers. I think only one. We'll see. Okay. The reason I'm pulling these out is I don't want to have the jokers in there. The jokers aren't supposed to be there. Okay, no picking cards. We'll do that here in a minute. Now, I don't think I have any more jokers. Oh, there it is. All right. Okay, now, in a traditional deck, how many cards are there? 52. Okay. There's a total of 52 cards. A lot of people don't know that. 52 cards, and that's not including the jokers. Jokers are just there so the top and bottom card don't get damaged in case if there's moisture damage on top and bottom. So the jokers are in there. Now, there's different suits. So like colors are part of the suits. But what are the 4 suits that are on the cards?
Hearts, spades.
Hearts, spades,
Diamonds.
spades. There's my spade. Diamonds.
And,
Starts with a C.
Club.
Club.
yeah.
Okay. Ignore my terrible artistic count. There we go. Alright. 2 of them are red. These are the reds. Hearts are red, obviously, and diamonds are red. The rest of them are black. Okay. Now, how that works in a deck, every face card or number has one of every type of those. So, for instance, if you have the ace, there's an ace for the hearts, spades, clubs, and diamonds. There's those 4 cards for the 2, the 3, so on and so forth, up to 10. Each of those cards have these 4. You have a jack of each of these, so hearts, spades, diamonds, and clubs. You have the queen and the king. So that's why there's 52s. There's literally 13 cards there, 1 through 10, 11, 12, and 13. And if you take 13 times 4, there's a total of 52 cards. Now, what a ratio can be is, let's say we're doing draw out of the hat. So we're going to draw a card. So Hannah, you're going to be my first guinea pig. You can draw any card you want. Now, name a card.
Jack.
Okay, you want Jack? All right. So Jack, do you want a certain face, or just any Jack? Okay. How many Jacks are there?
4.
4. So her chances of drawing, you can draw here in a minute. Her chances of drawing, there's 4 out of how many? 2. That right there is a ratio. Perfect. It's comparing how many there are in the deck versus the entire deck. It's comparing. It's doing the actual fraction. We could do a colon, like a semicolon, putting a colon between it. 4 out of 52. We could do it in word form. 4 of 52. We could divide and figure out her decimal. So if we take, in long division, we take 4 in the house, divide by 52 on the outside, her number is 0.07692. That's the decimal form of that. Or if I move the decimal over 2 spots, that's your percent. 7% chance. That's terrible, 7%. But there is still a possibility. It's not 0. She still has a possibility of doing it. So, Anna, any card you want. Okay. Did she get it? No. She was actually really close. She grabbed the queen. Now, if she keeps that card out, what happens to the ratio now?
So it's 4 to 51.
Yeah, now it's 4 out of 51 if we're still going for the jack. Your probability actually goes up. Every time a card's gone, you have better chances. You have better chances because that card is gone. That's the idea. Now, that's common sense. Most people don't. We're going to play a game. We're going to play a game.
Poker.
Not quite. Poker's a little bit challenging because there's a lot that goes into poker. It's not just the game itself. I mean, things that affect poker are the actual players themselves. There's bluffs. There's a lot of different things. Okay, so here's how we're going to do it. This is called the Monty Hall Paradox. It was a game. Okay. All right. So there are 3 cards. How Monty Hall? He was the host of an old game show. I believe Wayne Brady does it now. What is the name of it? It is. Let's make a deal. Okay. The show is very funny if you ever watch it. It's on, I think, right before Price is Right if you're ever homesick. Basically, people dress up in these crazy costumes. They go up there and Wayne Brady offers them a chance to win a prize. And all they have to do is, sometimes it's as easy as just pick a window. And then they say, okay, do you want to stick with it? So we'll do that. So, Cole, you're on. Pick any window you like. Now, what you're looking for here is you're looking for the ace. That's what you're looking for. Okay? Up there, 2 of those cards are jokers. 2 of the cards are jokers. I took them off the desk. 1 of them is the ace. Now, what is your probability right now? What is your ratio of you getting the ace?
1 of 3.
1 out of 3. That's not bad, right? 1 out of 3. That's a pretty good chance. In fact, if you take 1 divided by 3 on a calculator or a long divide, you get the repeating decimal, which is actually one of your homework problems, right? That is, if I move the decimal over 2 spots, that is 33.3% chance. Not bad. 1 out of every 3. So I'd like you to choose a card. Now we'll number these 1, 2, 3. So pick a card, please.
Number 3.
Number 3. So he's picking 3. So we're going to move 3 over. So this is number 3. That's the card you chose. Now we're going to do it kind of like we're going to change it up. Now we're going to make it kind of like the game show that. Say it again.
Briefcase.
Yeah, the one with the briefcase. I'm not going to show you your card. I'm going to show you one of the other cards, which is going to just annoy you because it's not your card. Now, this is the interesting thing.
You're going to say, would you like to switch?
Would you like to switch? You should. You should switch. Now let's talk about this. What was your chance of getting the right card? It's 1 out of 3. Correct? That means over here, there was 2 out of 3 cards left. Right? 2 out of 3 that you didn't choose. That percent over here, if you take 2 divided by 3 on a calculator, is this. That's 66.6%
But I said,
chance.
but I said
Okay.
from the fair side, which one?
Okay, so 66% chance the ace was actually one of these. Now, when I turn this card over and I revealed it to you, is this card the ace? So this card is not the ace. It's 0% chance of being the ace because I just revealed it. It's definitely not. That means this card here is all 66%. Most people go, oh, it's 50-50. No, it's not. The remaining two, that wall, that window, is all the rest of the percent. Because your percent, when you grabbed it in the original spot, has never changed. It was 1 out of 3. The remaining card is better chance. That's why in the game that they play with the briefcases,
Whoever
Deal or no
did
deal?
it-
deal or no deal.
Yeah.
That game, every time a suitcase is revealed, the percents are constantly changing. That's why the person up in the booth is always raising money and lowering money because they know the percent of the suitcases that are left. There is 66% chance that you should have switched your card. Okay, now, is it 100%? No. You still have 33% chance that you were right. But the math behind it says 66% chance you should have switched. Now, was it right? No. Because you had a 33% chance. In fact, 3 was the correct choice, but the math said you should have switched. Brave that you didn't. Okay, do we get the game? Okay, so now we're gonna make it bigger. So now you guys are all saying, oh, let's play poker. Okay, let's play poker. All right, poker's way different.
Play tournament.
Poker is a way different game because poker, you're playing 5 cards sometimes or different hands. Maybe you're playing 7 cards, and everything is based upon your neighbors next to you. The worst part is the deck always has 52. So when they play poker, there's a full deck of cards, and you're playing all of the people around you. And so the percents here are extremely difficult to calculate because you don't know what the cards are left in the deck versus what they're holding on to. You're basing judgment on how people are betting, how people are standing, how they're looking at their cards, that type of thing. There's a lot of subtleties to it. These types of games, this is called simple probability. Simple games. Poker is not, it's complex. Every card that's drawn affects everything else. Okay, question?
In casinos, poker's even worse because people started to figure out how to count cards, so they added like 4, 5, 6 decks in.
Yeah, so
there's
it's nearly impossible to figure out when you're in a casino and you're playing games against the house because if you're playing blackjack, there's 6 decks, 6 times 52. That's a ton of cards. Okay, that's 312 cards, something like that. Okay, that's not something that's an easy number to calculate. Okay, so that's why everyone always wants to play different games. But the easiest thing is doing simple probability, drawing a simple card out of the deck, that type of thing. Okay, do we understand the basics of proportions? Okay, we'll try one more. Now, do you have the jack anymore? Let me put it back. All right, put it back. So we're back to 52. Okay. All right. So we play the goal. All right, Sean, you get to do the honors now. You get to pick a card out of the deck. You can pick the card. You can pick the suit. It really doesn't matter. You can just pick the suit. You can pick just color. Choose what do you want to grab out of this deck.
A black queen.
Ooh, okay. A black queen.
No,
Okay. So
my bad.
on the queens, how many are black?
2.
2. 2 of them are black because every card has these. He chose the black. So on his probability, he wants 2 out of 52. Now, is that a better or worse percent than what Hannah had earlier?
Worse.
Worse. It's actually about half. So it's half of that. So it's about 3%. Because that percent is 2 out of 52. 2 of 52, which we divide on a calculator. 0.0384, so that is 3%. Now, is it 0?
No.
He has a chance. So, any card you like here, Sean, you get to do the honors. They're random. did you get 3?
No.
Okay, insanely close, got a 2. Okay, the percent of getting it was bad. Okay, it was bad because of the way that the cards work. Okay, now when the card's gone, the percent goes up. So how many cards are left? 51. Is that a better percent than what Sean had? Absolutely. It's a little bit better, not much.
Am I going for the same thing?
Same thing, Black Queen. Is that what you said, Black Queen?
Yeah.
Good one.
Black Queen, get it? No. Okay, so now, earlier, Sean drew, it was 2 out of 52. Dalton, you picked, you had 2 out of 51?
Yeah.
One less card. Check this out. 2 divided by 51. 3.0392. 3.9%. A thousandth better. Not much. 2 divided by 51. Yeah, 0.0392. Not much better. Not a lot better, but not much better. Okay. Alex,
Oh, God.
how many cards are left?
51.
50,
One.
no.
No.
50, okay, so 1 out of 50, or sorry, 2 out of 50. Black Queen.
I think I know it. Grab card.
Good card.
See it.
That's not.
No? Alright, so Drew didn't get it yet. So,
Not
On-
I found a night queen, but I haven't found one.
so now, we just drew a little bit ago. That was Alex's draw. It was 2 out of 50. Let's look at that percent. 2 divided by 50. That was 0.04 on a calculator. That is 4%. We're not gaining a lot. Not gaining a lot. It is getting better. Not much.
We're all red.
Okay, so far all red. That's
I
good.
have Jason.
I picked the
Hey,
hardest
Jason.
card
Yeah, come on.
How many cards are left?
to get.
59.
49, alright. So,
I picked the hardest one.
got a
We got
black 3, but that was 2 out of 49. Now, better percent. How much better?
A little bit.
Probably a thousandths again? Not even. 0.0408.
Oh,
We're not gaining much. We're getting better as we go. Okay.
I got black.
Now,
You're the closest so
we've
far.
done this so far, we can keep going. What is the worst percent we could have?
0.
0. What's the best percent?
100.
100. Are we gonna get to 100?
No.
Eventually we will. Eventually, if we get down to the last card, and it's a Black Queen, but the probability of getting to that is pretty low. The probability of getting 0 is pretty low. We're always gonna be in these marginal things. That was just a simple card game. That's not playing poker or anything like that, where there's 5 cards or 7 cards or something like that. Percents are low. Okay, it's one of those things I always find it funny to do. Okay, any questions with the games that we played here today? We're gonna do a couple more games tomorrow. The games that we're gonna play tomorrow are gonna be a little more entertaining. These are just kind of simple games.
We should go
Okay,
around.
I'm gonna walk around and collect the cards. It's gonna take a while. Yeah, I'm gonna grab myself.
We're with the queen.
That was lucky. That was lucky.
Right.
Fucking close. Ish.
Alex, you wanna play poker later?
Alright, hey, you have the rest of class today to work. Page 116, make sure you are getting that done. You should be working on it unless you have it turned in. I believe I only have it from one person today, and that is Jason. So everyone else should have their matchbook out and they are working on it. So nothing else out in front of you.
Yeah, I finished. Oh, no, I didn't.
Miss Mitchell, you said you went to Vegas.
Mm-hmm.
What was one of the games you did play?
I just played slots.
Ah, okay. All right, I was
I
hoping
wish
you
I would
played
have done black.
craps or blackjack.
I wish I understood it.
Okay, I'll explain to you right now.
Okay,
Easiest game in the world.
craps
It's
is?
actually, yeah, craps. It's actually really entertaining to play.
That's what I've heard, and people look like they're having such a great
They
time
are.
when they're
It
playing.
is one of the most entertaining games. It's the one game in the casino, the only game in the casino you have a better chance in the house of winning.
Really?
It's the only game. Everyone thinks, oh, roulette or something. No. Craps. That's why people play it.